Hi, this is a screencast on how to name alcohols using the IUPAC naming rules, and a little bit about the physical properties of alcohols and what to expect with them. So, first of all, we should recognize and realize that alcohols contain this functional group, which is called a hydroxyl functional group. Okay, so when you see the hydroxyl functional group, the OH attaching to any carbon chain represented by R in this case, you know you're dealing with an alcohol. So the family and the class is called alcohols. There are also what we call primary, secondary, and tertiary alcohols. So we'll look at what the difference is between those. All right, so let's have a look at a small alcohol like this guy right here. Okay, 2 carbons and a hydroxyl group. So in naming this, we do our typical naming stuff. We look at what is the longest run of carbons. Of course, there it is. It's 2 carbons. And so we know that a 2 carbon run is going to have the prefix eth, right? So instead of, like for a hydrocarbon, how the suffix might be ethane if it's all single bonded, or ethene if it's got a double bond, or ethyne if it's an alkyne with a triple bond. Alcohols all get the suffix -all, okay? So this would be ethanol. All right, there's only one place in this case. The position of the hydroxyl isn't really that important for ethanol because there's only one place it can be. It has to be on one of those carbons. So this would be called ethanol. So if we look at ethanol, it's fairly representative of most small alcohols. This would be a water-soluble compound. Okay, so it's water-soluble. What helps it be water-soluble? And any small alcohols are water-soluble. What helps it be water-soluble is it has this hydrogen bonding capability with water. So because it has this OH, the hydroxyl group, remember that a hydrogen bond is always a strong force of attraction between an N, an O, or an F on one molecule and an H on an adjacent molecule. So it would be, in this case, the oxygen here in the hydroxyl group will always form a strong attraction to the H on any adjacent water molecules, and it'll form a strong hydrogen bond there. So it's always going to be very soluble in water as a result. And most alcohols are water soluble, especially the small ones. All right, what's drawn here is what we would call a homologous series of alcohols, and you should be familiar, I hope by now, with this term, a homologous series. You'll notice that in this series of alcohols, starting with ethanol, and then carrying on to propanol, and then butanol, and then pentanol. So as we go one to the next in this series, we are adding a CH2 unit each time, right? So we're adding one of those CH2 units, and we're just expanding the chain each time. So that's what makes this a homologous series of alcohols. And what you should realize as you progress through a homologous series of pretty much any organic compounds, but alcohols can be representative for that, is that you're going to see, as you go from smaller to larger, that the melting point and the boiling point increases. So we're going to see that the melting point increases, the boiling point increases. Why is that? Well, as these molecules get larger and larger, they have a greater dispersion force, or London force, between them. And this is an intermolecular force that is dependent on the number of electrons in the compound. So because we get an increase in the number of electrons in the compound as we go from the top to the bottom, we're also getting an increase in melting point and boiling point. In other words, it takes more energy to separate one molecule of pentanol from a neighboring molecule of pentanol than it does to separate one molecule of ethanol from a neighboring molecule of ethanol. In all of these alcohols that have been shown so far, they have all been a certain kind of alcohol called a primary alcohol, okay? And what makes this, and of course this is propanol. And what makes propanol, and if I'm a little bit lazy and I don't write it, if I don't put the position, I should actually say propan-1-ol, because it tells you that the hydroxyl group is on carbon 1. Okay, but these are also what we call primary alcohols. The reason they're primary alcohols is if you look at the carbon and focus on the carbon that the hydroxyl group is attached to, it is what we would call, in this case, a primary carbon. Okay, so this is called a primary alcohol. If we look at a different carbon in that structure, so if we look at the one that's circled in red, this carbon is what we call a secondary carbon. The final one on the end is also a primary carbon. So can you figure out what the difference is between a primary carbon and a secondary carbon? Well, if you look, a secondary carbon is actually touching or bonding to two other carbons. That's what makes it secondary, whereas a primary carbon is only bonding to one other carbon, right? So they're called primary. So in a primary alcohol, we have the hydroxyl group bonding to a primary carbon, and that's what makes it a primary alcohol. So you could probably take a guess, and you can pause the video and come up with it on your own, but can you draw a secondary alcohol? And can you draw a tertiary alcohol? That might be a bit of a challenge. All right, so secondary alcohol, and again, we can draw what is called an isomer of propan-1-ol. We can draw propan-2-ol here. Propan-2-ol, all we have to make sure we do is that we put that hydroxyl group on the middle carbon, because that's a secondary carbon. So that makes it a secondary alcohol. And the name of that alcohol is propan-2-ol. We can't really make a tertiary alcohol that's a structural isomer of that one, but we can make a completely different tertiary alcohol. We just have to make sure we have a tertiary carbon. So if we make a carbon that attaches to 3 other carbons, all of a sudden we have generated a tertiary carbon. Okay? So if we put the hydroxyl group on that tertiary carbon, that is a tertiary alcohol. There you go. So this is a tertiary alcohol, and the name of this alcohol, again, take a second, pause it, and see if you can come up with the name. The name of this alcohol, longest run of carbons, is still 3. Okay, and then we would have a methyl alkyl substitute and the hydroxyl substitute, both on carbon 2. So the name of this would be 2-methyl propan-2-ol. I almost had space for the whole thing. 2-ol. There we go. Alrighty, a little bit of practice here. So the first one, let's come up with the name for the one at the top. We have the longest run as 4, so we know that's going to be a meth-eth-prop-bute. Alright, so we know this is going to be some kind of a butanol. What carbon is the hydroxyl group on? It's on carbon 2. So it's going to be butan-2-ol. That's how you would do that. Now, one more question I might expect you to know about this is this a primary, secondary, or tertiary alcohol? And because it is on that carbon, and the nature of that carbon is that it's a secondary carbon, it bonds to 2 other carbons, this would be a secondary alcohol. Moving right along to that next one here. This is an interesting one because there are actually 2 hydroxyl substituents, okay? 2 hydroxyl functional groups. So this is going to be what we call a diol. So the longest run is 3, right? So that makes it some sort of a propanol. It's actually a propanediol. And the way we would write that out is we would say it is propan 1,2-diol. Okay? Then we get to the last one here. So the last one, again, identify the longest run of carbons, and you should see that 4 is the longest run you have in the structure, okay? So that's also going to be a bute, okay? Then you have to figure out how are we going to number this. We have the hydroxyl substituent here, and then we have a methyl alkyl group here. So is this going to become carbon 2 down here or carbon 3 down there? Is it going to be carbon 2 up here or carbon 3 up there? What gets priority in the naming? Well, it turns out what gets priority in the naming is the functional group, right? So we would name it to give the hydroxyl group the lowest number possible. So we're going to name this one, what did we say? It's bute. We're going to name it, so it's going to be definitely a butane 2-all, okay? And then we have to accommodate that methyl group. We're going to call that 3-methyl. 3-methyl butane 2-all, just like that. By the way, is that one at the bottom a primary, a secondary, or a tertiary alcohol? Of course, it is a secondary alcohol because this carbon is a secondary carbon. Hope you found this helpful.